Hello and welcome to the video on Basic Reading Files in SAS. This video tells us that how SAS reads the data that has been fed into it. It is very important to know how the data is read by SAS before we delve into analysis. How the data will be taken into the system depends on how the analyst receives the data. There are 4 basic ways for that. Firstly, hard copy data like questionnaires. The data has to then be entered into the system manually. Mind you, this is the worst case scenario. Second is the split data, where the header and values are in different files. Third, data comes in soft copy in some other softwares like Excel, CSV or any other format. This data has to be then imported in the SAS program. This is the most common way of getting the data in a corporate scenario. The fourth and the last way is that data comes to you in the SAS format only. This is the best case scenario. Here, we do not have to do much with the data. Let us start with the worst case scenario, that is, getting data in raw format through hard copy. Here, we will have to type the data into the system. We open the SAS window and see 5 tabs at the bottom of the screen, namely Results, Explorer, Output, Log, and Editor. The editor window is where you do the coding, that is, it is the place where you write your codes. Log window is where the results on the execution of the codes is given. Whether there were any errors or not, how was the execution done, which command was successfully run, etc. The output window is just like the print preview window in MS Excel. Before printing any data or report, we can view the output window first to get an idea as what the printed statement would look like. The Explorer window consists of the library and various files stored in the system. Library is the place where you store your files or data sets. When you click on libraries, you see 3 types of folders. In higher versions, you will see 4 types of folders here. The 4 types are SAS User, SAS Help, Map, and Work. SAS Help and SAS User are permanent and default libraries. Work is the only temporary library in SAS. SAS Help and SAS User consist of many files and datasets that the students can use for their learning. We can see a couple of examples here by clicking on one or two of them and seeing the data on the right window. Work library, as mentioned, is the temporary one. Apart from this, we can create new libraries also. To create a new library, go to the new library icon as shown. Once you click on it, a dialog box will open for details. You have to give the name of the library, which cannot have more than 8 characters. No space, special characters or numbers can be used while naming the library. Only text has to be used. Suppose we create a new library by the name DataF. Then we have to give the path of the library, that is, which folder are we going to assign to this library. This is done because when you create this file here on the left, It will go away once the session is closed. The file or folder that you have used for this will then be saved on the path assigned by you. Let us open this and go to D drive. Create a new folder and name it for SAS. And then assign this path to the library. Once we click OK, we can see a new library on the left panel. Data F, remember, is our permanent library. Work, remember, is the only temporary library. If we keep any data in this, we will lose the data once the session is closed. This won't happen if we keep the data in data F though. That information will be secure in the location given on that path. Results window is where we get the output. The output can be reports like graphs, charts, proc reports, etc. Let us now come to the editor tab. We will see how we can create a data set manually. To create a data set or to manipulate it, we need to use the data step as mentioned in the first video. For analysis or reporting, we use the proc step. Since we are creating data here, we will use the data step. For data step, we start with the keyword data and end it with the run keyword. All the commands, statements, and instructions written between the words data and run together is known as the data step. Thus, a data step consists of multiple statements. A statement is a command. It has to be a complete sentence starting with a SAS keyword and has to end with a semicolon. For example, data is the keyword here and is coming in blue color. Whatever we write now and then end it with a semicolon, the whole sentence is then called the command. Coming back to the data step, we wrote data and then we hit spacebar. After that, we have to write the name of the file that we want to create. Suppose we want to create a file named class1. There are some conventions for the naming of these data sets also. No space is allowed here. No special characters except underscore. It cannot start with a number and it cannot be numeric name only. Now that we have named the dataset class1, the next question is which library do we have to store it in? For this, we go to the Explorer tab and decide whether to save it in work or data F. Once decided, we put the name of the library before the dataset name. For example, if it is work, then we write work.class1. And if it is data F, then we write dataF.class1. Remember, if you save it in the work library, then you will not be able to retrieve it after the session. Also, if you forget to assign any library to the dataset, then it goes to the work library by default. Therefore, if the dataset you are working on is of temporary nature, then you may wish to not assign it to any library, since by default it will go to the work library only. Now our statement or command is that we want to create a dataset with the name class1 which will be stored in the work library. To end the command, we type semicolon. This is now a statement. We now press enter. The new statement starts with the keyword in file. This statement tells us where the values are located. Data will have two parts, headers and values. This statement will tell us where these values are. If we have a file already made in text form or a CSV form, for example, then we can give the path to that file over here. However, remember, here we are creating data. Thus, we do not have any file to give for values. In such a scenario, we write data lines. Data lines will be that keyword which we will use in the future. All the values will follow this keyword. Again, to end the statement, we press semicolon. Next comes the input statement. This statement tells us what headers will we have in our dataset. Suppose we have three headers: name, age, and amount. To again end the statement, please do not forget the semicolon. We separated all the headers by a space because in SAS that acts as the default separator. Now we type data lines as the keyword. We close the statement right after data lines, and now we will start putting the values. For example, the name is Rajesh, age is 25, entered with a space, and amount is 20,000. The next record is named Vidhi, age 23, and amount 15,000. Naresh, 32 and 18,000, and so on. Now when we want to end it, we cannot put a semicolon after the last entry because it is not the rule that we had discussed earlier. A statement should start with a SAS keyword and end with a semicolon. Over here, if we put a semicolon, then SAS software will start reading Naresh as a keyword. And because it is not a SAS keyword, it will be highlighted in red, signaling an error. To end the values, we put the semicolon in the next line. This is just a blank semicolon. And lastly, we type the run keyword. This is now a complete dataset, starting from data and ending at run. This dataset consists of 6 statements. Just count the semicolons. The speciality of SAS is that it has an open format, which means that multiple statements can be written in a single line and a single statement can be written in multiple lines. For example, we can write all these statements in a single line over here. Also, a single statement can be written in multiple lines and can be demonstrated like this. This is because SAS looks at the keyword and the semicolon. Everything in the middle is a statement or a command, hence it does not matter if it is written in a single line or multiple lines. Now that our data step is ready, we select and click on the submit icon for it to run. Remember, since we did not put a library name, this would have gone to the work library by default. Let us go to the work library and click on it. We see there is a file in it named class1, and when we click on that, we see that the dataset has been created. But there is an issue. The issue is that the name has not been read by SAS. Age and amount have been recorded correctly but not name. By default, all the numeric data is aligned to the right in the output and text data is aligned to the left. Name was a text field, but here they have been given as dots which indicate missing values in SAS for numeric data. For any value missing in text variable, it is denoted by a blank. Thus, there are two issues. One, that the values are missing, and two, it is being shown as a numeric field since it is aligned to the right, whereas it should be a text field. This is because if it is not explicitly mentioned, SAS reads all data values as numeric only. Thus, in our example, it is expecting all the headers, name, age and amount to have numeric values. And since it is not getting numeric values under name, it is unable to give us any output in that column. Thus, to convert this into text format, we use the $sign after the variable header. SAS will now expect text values for name. Let us now run this and check whether we get the correct result or not. We see the first column under the name header has the values shown as well now. Next scenario we see is that if we already have some data with us. Suppose we open some data in the text format. The data here is 4 cities followed by their respective minimum and maximum temperatures. We add a couple of more cities to this. We go to the SAS session and start another data step with the keyword data. We name it class 2 and save this in the data.f library. In the in-file statement, we will now give the file path for the data. We go to that file and get the file path for the same. To open the run command, we press Windows + R. We copy the file path and paste it in SAS. Then we start the input statement, which will have headers, city, followed by a dollar to signify it will have text values, minimum temperature and maximum temperature. Remember to not give any space in the header names. We do not require the data line statement here since we do not have to type the values. We type the run command now. Now we select this data step and run it. We go to the data.f library and see the file that has been created. As we open the file, we see that the whole table has been created. Thus, we have seen two scenarios now. One in which we created data and the other in which we had data in some text format. We now look at the third scenario where we have some data with us in the Excel format. This file has both the headers and values created together. Thus, we do not need to create it again. This means we do not use the data step altogether. we will directly import this data into SAS. To import, we first require the path of the file. We take the file path of the Excel named array. We use the keyword proc import. Remember, proc stands for procedure. This is followed by data file. This tells us which file we need to import. Now, where will the Excel file come to? That is, to which library? For this, we define the out statement. We name this as class 3, and since no library is assigned, it will go to the work library. Then we tell SAS which type of file is it, that is, the Database Management System DBMS. In our case, it is Excel. Lastly, we write replace and put semicolon. Replace command is not mandatory. It ensures that if there is another file by the same name in that library, then this file will replace it. And then we run the command. Look at what we have done over here carefully. First, we imported the file. Second, we provided the path. Third, we named the dataset and provided the library to which it should be stored in. Fourth, we mentioned the type of the database management system, the DBMS being imported. And finally, given the command to replace prior existing files of the same name. When we see the output now, we see the whole Excel table imported in SAS. Last scenario is where we have a dataset in SAS format already. Say we have a file in SAS help. We write data, name it class 4, give a command set which helps us copy any data from the prior datasets. We write set and then provide the library which is SAS help and then the file name class. Finally, we run the command. This output can be seen in the work library. We now see we have the third file by the name class 4 over here. Thus, we saw the 4 methods by which we can get data in SAS. Thank you.